Welcome back to another episode of Math with Mr. Young. So today we're going to be working with lesson 8.1 integers. Our standard is 6th grade number sense C, and our objective is that we're going to be able to understand the concept of negative numbers and that they are used along with positive numbers to describe quantities. Our mathematical literacy, we have positive numbers, negative numbers, opposites, and integers. Alright, lesson 8.1 integers. Our success criteria is that we're going to be able to write integers to represent quantities in real life. We're also going to graph integers on a number line, and we're also going to use and find the opposite of an integer and apply these integers to model real life problems. Alright, for our mathematical literacy, we have integers, we have positive and negative parities, and opposites. Alright, first of all, I just want to talk to you guys about a number line. Now, a number line, it could be, your y-axis. Okay, and another number line could be your x-axis. Alright, just to begin. Alright, so these are number lines. Now, these number lines, they do consist of real numbers, rational numbers, integers, whole numbers, and natural numbers. All right, but let's focus on integers. And integers are basically whole numbers and natural numbers, and they do include negative and positive parities. What that means is negative and positive numbers. All right, so with that being said, let's go ahead and talk to you guys a little bit more about opposites and positive and negative numbers. Now, just remember that positive numbers, these are used to describe quantities that are greater than zero. Okay, quantities. So if we have the origin, we're talking about zero here. Zero is what we call a neutral number, because zero here is not positive, nor is it negative. All right, it's a neutral number. So that is that's what the origin zero does. All right, it's neither positive or negative. Okay, one more time, positive numbers. These are numbers used to describe quantities that are greater than zero, and negative numbers are numbers used to describe quantities that are less than zero. And just remember that most times or often, positive and negative numbers that are going to be used to show quantities that have opposite directions or values. All right. So, and also just remember a reminder that all positive and negative whole numbers without fractions or decimals, whole numbers, these are called integers. So we have examples of these integers. Now we have opposites as well. Okay. Now, when we have a positive and a negative, all right, positive and negative, so these positive negative signs are called opposites. So if we have positive 5 and negative 5, these are called opposites. Positive 5 and negative 5, they are opposite of each other. All right, and just remember that they are both the same number of spaces or the same distance from zero on a number line, but on opposite sides. For an example, if we have negative 4, the opposite of negative 4 is positive 4. All right, and here's your origin, 0. Your origin is 0. It's a neutral number. All right, and all your positive integers, okay, are to the right side of 0. Positive 1, positive 2, positive 3, positive 4, all the way to positive infinity. All right, also you have negative numbers. Okay, negative integers. Again, they are basically on the left side of the origin, a neutral number. You have negative 1, negative 2, negative 3, negative 4, all the way to negative infinity. All right, so let me draw that better. That looks like a negative 8, but negative infinity. Okay, opposite directions. One more time, these opposite, let's say here, negative 3, the opposite of negative 3 is positive 3. The opposite of positive 2 is negative 2. The opposite of negative 1 is positive 1. All right, so again, they are the same distance from 0 on opposite sides, and 0 again is the indicator that would be the neutral number. So on your y-axis, same thing, the vertical number line. You have 0 here. The numbers below 0 are going to be negative integers. The numbers above 0 are going to be positive integers. All right, and we'll talk more about this as we go along, but I just wanted you guys to be introduced to number lines. Your vertical number line, your y-axis, your horizontal number line, your x-axis. Okay, and also introducing you guys to integers and just reminding you that they are whole numbers and they include positive and negative parities. All right, and of course you have opposites. So this is what 8.1 is all about today. All right, in our first example, we're going to write positive and negative integers. All right, we're going to read a few passages, and all we're going to do is write these numbers. All right, so it's pretty basic. All right, let's listen. So let's look at number 1. All right, and I'll read in verbatim. That means word for word. A contestant gains 250 points on a game show. So look for keywords here. All right, what tells you to increase or decrease? So it looks like the word gains here tells us to increase by 250 points. So that's going to be plus 250 points because this contestant gained 250 points on a game show. That's going to be a positive 250. All right, that's all we do when we write positive integers and negative integers. So let's look at number 2. Gasoline freezes at 40 degrees below 0. Okay, so the word below tells us that's going to be negative. Okay, we decrease that number, and the gasoline freezes at 40 degrees below 0. All right, minus 40. Number 3, a hiker climbs 900 feet up a mountain. Climbs and up. They indicate that we're going to increase by 900 feet. Okay, so we increase elevation by 900 feet by hiking up a mountain. All right, plus 900. Now, number 4, you have a debt of $24. So if you use a credit card, you're borrowing money from a bank that you had to pay back. If you use that credit card to purchase something, you're going to be in debt to the bank by $24. That means you owe money to the bank. All right, that's what the word debt means. Okay, you probably heard about a debit card. A debit card and debt are two different things. All right, so just remember that. Spelled differently too, by the way. So one more time, anytime you have a debt, you have to pay that back. Okay, so we're going to go ahead and graph integers. And our directions tell us to graph each integer and its opposite. Okay, so we're going to have to graph each integer and its opposite. So I have 4 example problems here. I have 2 different types of number lines. I have your vertical number lines, also known as your y-axis. I have a horizontal number line, also known as your x-axis. Okay. Now notice that you have your neutral number 0, your origin. Now I will tell you, you always start from your origin. No matter if it's on your x-axis, your horizontal number line, you always start. That's your starting point. Think of it like you're playing a board game like Sorry or Monopoly. You always have a starting point, and that's what the origin is. The origin is always your starting point. That is where you begin, and that's what origin means. It means begin. Okay. All right, so here we go. So again, our directions tell us to graph. We have to graph these integers and its opposite. So in this case, let's look at A here. Okay, we have the number 3, and that's going to be a positive 3. So let's find positive 3. Let's locate this on this y-axis, the vertical number line. So right there's positive 3. All right, so here's your origin, your starting point. You go up 3. I'm going to graph that there. Boom, that is it. I'm done. Oh, it told us and its opposite. So what is the opposite of positive 3? Well, negative 3 would be its opposite. All right, so there we go. We graphed positive 3, the integer 3, and its opposite. Let's move on to B. Now we're going to graph the integer negative 2. Now the opposite of negative 2 is positive 2, okay? Now we locate both of these guys on the vertical number line, your y-axis. So start from your origin, and we're going to look for negative 2. So we go down 2. So here's negative 2, graph that. And then go ahead and again start from your origin and find positive 2. There's positive 2, go ahead and graph that. And there you go, my friends. You have graphed the integer negative 2 and its opposite, which is positive 2. And if you notice, positive 2 and negative 2, they are both 1, 2. They are 2 spaces, 1, 2. They're 2 spaces from the origin. They're 2 spaces from the beginning, okay? So we'll get into that when we talk more about absolute values. But for right now, let's just understand the basic concepts. All right, letter C, problem number 3. So we're gonna graph on this horizontal number line, your x-axis now. Same thing, the same concept. We always start at the beginning, the origin at 0, our neutral number. On the left side, we see negative parities. On the right side, we see positive parities. In other words, what I'm saying is we start from the origin. This is our starting point. On the left side of it, we have our negative numbers. On the right side, we have our positive numbers. So we have positive 4 here. The opposite of positive 4 is going to be negative 4. Now again, you start from 0, the origin, and locate positive 4. Well, I go to the right, and here's positive 4. Same thing, start from your origin. Now we look at negative 4. So on the left side, you see negative 4. Again, so here's the origin. We're 1, 2, 3, 4 spaces from 0 for negative 4. And here's your origin again. We're 1, 2, 3, 4 spaces away from 0. So negative 4 and positive 4 are 4 spaces from 0. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. All right. So again, we'll talk more about that as we talk about absolute values at a later discussion. Last one. We have this integer 1. The opposite of the positive 1 is negative 1. Both positive 1 and negative 1 are both integers. So we have the integer 1 and its opposite negative 1, and we locate them and graph them on the number line, the horizontal number line, also known as your x-axis. Start from your origin, and positive 1's 1 space to the right. Start from your origin, and negative 1 is 1 space to the left. So there you go. You have graphed negative 1 and positive 1. So again, it's pretty basic, straightforward, and simple. Again, knowledge is not free. You still have to pay for it. If you're not paying with currency, you're paying for it by paying attention. All right, so hopefully you're paying attention. All right, the last one we have is a word problem, modeling real life. All right, so I want you guys to imagine that you have a side business and you deliver flowers, okay? So you're gonna be delivering flowers, and we're going to an office building, okay? I don't think we have many multi-story buildings here on the Navajo Nation, but I want you to imagine that if you were to go to a big city, you do see bigger buildings and skyscrapers and all that good stuff. But keep that in mind, all right? So you're going to deliver flowers to an office building. You enter at ground level. In other words, ground level will be the origin, the beginning, okay? So here's 0 on this the y-axis, the vertical number line. 0 right here would be ground level. All right, so here you are walking into the building. Here's the door, and there you enter. Now below you do have like 4 floors below ground level, and you have 7 floors above ground level. All right, so I want you guys to remember that. And again, this is ground level right here, okay, of this building. So one more time. You're going to deliver flowers to an office building. You enter at ground level and you go down 2 floors to make the first delivery. And then you go up 7 floors to make the second delivery. So we're going to have to go down. As soon as we enter, we take the elevator down 2 floors. So you go, I guess the basement floors here, and you make your first delivery. And then it says you go up 7 floors. So we went -2 down here to go in from the origin ground level to deliver our first set of flowers. From here, again, you go up 7 floors. So 1, 2, 3, 4, 5, 6, 7. Boom. So you're going to go +7. So you went up 7 floors to make your second delivery. Okay, so I'll put first delivery, second delivery. All right, now you're done. But you're not going to stay there forever. You still have to go down 5 floors to get to ground level to leave the building. All right, so I just want you guys to understand that. And here I'll just write the word position. So first of all, you entered at ground level, and then you go down 2 floors, and then you go up 7 floors. Okay, so the integer that we have, okay, if we were to enter at ground level, we start off with the origin at 0. And then when we go down to make our first delivery down 2 floors, we're at -2. And then we go up 7 floors to deliver our flowers for the second delivery. So that's +7. And let's see here. And then when we have to leave the building after making our second delivery, we have to go down 5 floors to get to ground level again, just to leave the building. Okay, so we ended at -5. The integer representing down 5 floors is -5. All right, so I want you guys to understand the concepts of placement with these positions of integers on number lines. So that's basically it. So there we go, my friends, and that's all we have to do with integers. Pretty basic, straightforward, and a lot of fun. By now, you should be able to write integers to represent quantities in real life. You should also be able to now graph integers on a number line, vertical number lines, horizontal number lines, basically your X and Y axes. And also, you should be able to find the opposite of an integer and apply these integers to model real life problems. And don't forget, students, to ask questions, and we're here to help you guys.